Okay, so you somewhere in your packet have an example. It says example one. I didn't get the page numbers, sorry about that. But it should say this. So just look through your packet, pause me, and see if you can find this one. Okay, so I wanted to go over that because I was like, ask him, ask him. But anyway, so if you remember when I was talking with you yesterday, and I was saying that when, oops, let me put my pointer on. When you have a limit as x approaches any kind of infinity, you look for n behavior, meaning you take the highest power. Remember, I had ones with fractions where you take the highest power in the numerator and the highest power in the denominator, and then you would just reduce it. Well, since this isn't a fraction, all you do is you just take the highest power. These are all smaller. So basically, let me just kind of give you a general gist. So then what I would write here then is I would say then the limit as x approaches infinity. Basically what I'm going to be doing is I'm going to be looking at just the highest power. So I'm getting rid of these mentally. Okay. And then from there, all I'm going to do is I'm going to plug in infinity. Let me get my pointer. So I'm going to be plugging in infinity for my x. Okay, so that would be 3 times infinity to the fifth power. Okay, now let's think about this for a second. Infinity is a really big number. If you raise it to the fifth power, it's even bigger. And then if you multiply it by 3, it's even bigger. So this whole thing is going towards something larger and larger and larger and larger, aka, I'm going to put it over here, I'm going to squeeze it, infinity. That's your answer. Okay. All right. So I purposely skipped B because when I took screenshots, I didn't have a B in any of my pictures. So I don't know what B was. Hopefully it was something we could do. If not, just next time you see me, ask. Okay, and we can go over that one. All right, so now let's look at C. So the limit as x approaches infinity of e to the negative x. Okay, so what I kind of would like to do is rearrange this. So I'm going to make this as the limit as x approaches infinity, because remember, we did this as a picture, and you really don't need to know the picture. Remember, I was saying hold on, back up. You really should know what e to the x looks like and e to the negative x looks like. But if you don't, I'm going to show you the non-graphic way of doing it. Okay, so hopefully you remember just based upon algebra that when you have a negative exponent, you can get rid of it by putting it in the denominator. So that's how I got this. Okay, and again, this is providing you don't know what the graph of this looks like. I did this with you, showing you what the graph looks like, which you're supposed to know. But anyway, okay, so then I'm going to do the same thing as I did in part A. So what I'm going to do is I'm just going to plug in infinity for x. Why? Because this says x approaches infinity, so I'm putting x to be infinity. Okay, now let's think about this. E is a number. Okay, it's 2 point blah, blah, blah. So 2 point blah, blah, blah to the infinity power is a really large number, isn't it? So this is really 1 over a very large number. Now, remember what I said to you yesterday. If the larger number is on the bottom and we have a limit as x approaches infinity, wouldn't that mean that goes to 0? Okay, so that's how you can do it algebraically without a picture. Okay, so we're going to go and we're going to look at D. Okay, so D, I am going to, all right, we'll do this the same way as I started doing as x approaches negative infinity, right? And I'm going to make this 1 over e to the x, okay? Again, because anything with a negative exponent, we can make that exponent positive if we bring it down. Okay, now from here I'm going to do what I did on part C, and I'm going to plug in 1 over e to the negative infinity. Okay, now I kind of don't love the fact that I've got a negative here. So let's think about this for a second. Remember, If I have a negative exponent, I can make that exponent positive if I change its position. So in other words, this was in the numerator, I put it in the denominator. This was in the numerator, I put it in the denominator. This is in the denominator, guess what I can do? I can then take this and put this in the numerator, technically over 1, okay? And what that's doing is it's getting rid of that negative exponent. Now think about this. This is 2 point something to a very, very large number. So wouldn't that be a super duper large number? And wouldn't a super duper large number be infinity? Okay, again, D you can do if you know what the picture looks like, but if you don't, this is the way you can reason that out. Okay, all right, let's look at part E. It says the limit as x approaches infinity of sine x. Okay, this one, I think we did go over this. I don't remember, so I'm showing it to you just in case we did not. Remember what a sine x looks like? Let me just see, E. Oh, I have E on my paper as going toward a positive infinity, not a negative infinity. So I'm just going to go like this. Okay. All right. So sine x looks like that. But this is going on forever and ever and ever. And well, we could just keep going. But remember, we talked last night about this is a positive one and this is a negative one. So what this graph does is it oscillates. In other words, it constantly repeats, never going above 1, never going below -1. So when that happens, your limit as x approaches infinity, we discussed this last night, that would be equal to a dne. Now, by the way, just because I don't really remember if I copied this right from the picture or not, if this was a negative infinity, it's still going on forever and ever and ever, so it would still be a dne. Okay? Okay, F. So I looked this one up. I'm hoping that I am right. I would double check with him just to be on the safe side. There were 2 different ways that I saw online that we could do this question, so here goes the one way. Okay, so what I'm going to start with is I'm going to start with just this sine x here. Okay, and let's go back. Here's the picture, right? So I want to kind of compare it to this because these are very similar, except that this one is approaching a negative infinity and this one's a positive, I believe. Okay, so if I look at this graph, right, would you agree that the sine x graph fluctuates between a -1 and a +1? Okay, makes sense, right? However, the extra bonus is we've got this x here. So what I'm going to do is to get this to match this phrase, which is x sine x, I want to put an x in here. But if I put an x in here, I've got to put an x in here, and I've got to put an x in here also. All right, so what I'm going to do then, essentially, is I'm going to take this, and I'm going to multiply every term by x. Okay, so then on the far left here, I'm going to have negative x. Then in the middle here, there's my x sine x, which the original limit has. And then over here, I have a positive x, right? Okay, so all I did was I distributed this x through to here, here, and here. Boom. And then this matches this. And now all I'm going to do is plug in negative infinity here and here. Now there's a reason why I'm not plugging it in here, because you were not there, but they learned the squeeze theorem or the sandwich theorem. You and I talked about it. Remember, if you get the same number here and here, the answer is that number. If you don't, then the answer is dne. Okay, so watch what happens. So if I put in a negative infinity right here, that's negative and then negative infinity, right? Okay, so just this negative here is this negative, and then x is negative infinity. Okay, then I'm going to keep my less than or equal to x sine x, and then over here, I'm plugging in negative infinity. Well, on the far left over here, I get infinity. And then over here, oops, I get x sine x. And over here, I have negative infinity. These two, bing, bing, those are not the same. So in that case then, if they're not the same, your answer is D and E. Okay, so G is kind of very similar to what I had right here, except instead of an x, I have a 1 over x. So I'm going to start with this again. So hold on, let me go back to my pointer here. We know that sine of x is between negative 1 and 1, right? So all I'm going to do is I'm going to recopy that. There we go. Then I'm going to multiply. So over here on the left, I multiply by this x. So this time I'm going to multiply by 1 over x. 1 over x. And then this is what I get. Okay, and now remember what we did over here. Once we got this, then we plugged in our limiting value, which was negative infinity. In this case, it's positive infinity. So then I'm going to get negative 1 over infinity less than or equal to 1 over x sine x. And then over here, 1 over infinity. Okay, so let's give this a little bit of a analyzation here. All right, let's start over here. I like that because we don't have to worry about the negative. 1 over something very, very large. Remember what I said that was? Okay, from last night, that is going to end up being 0. Okay, now over here on the other side, I still have 1 over something very large. So that's still 0 times negative 1, which is still 0, isn't it? Okay, so then over here, this would also be 0. And since these two things, boom and boom, are the same, then your answer is 0. Okay, somewhere in your packet, I don't know where, I don't know the pages again, you've got this picture. Okay, so if you want to pause me and find that. All right, so here we go. So when we have compositions of functions, if you remember from Algebra 2, we start inward and then we work our way out. So I'm going to start by looking at this f of x and finding the limit as x approaches 6. Okay, so I'm going to come over here and I see here's where x equals 6. And remember, if there's no little plus or minus here, that means you need to look from the left and from the right. Okay. So as I come from the left, I'm just going to draw arrows, see? And if I come from the right, do you see the y value that this graph approaches is 2? Okay, so then what that means is I am going to put a 2 here. Okay, hold on. Now, the other thing I want you to notice is look at all these y values and all of these y values. Aren't these, like this y value, let me see, 1, 2, 3, 4. I don't really remember exactly. Hold on, let me just see. 1, 2, 3, 4. So this is at 5, right? But then we go to 4, to 3, to 2, to 1. So all of these y values are higher than 2. And all of these y values are also higher than that 2. So because these values are bigger than this y value of 2, bigger, would imply then that we need a plus sign here. Okay, because we're looking for numbers that are bigger than 2, and numbers that are bigger than 2 are like 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. And that means we would need a plus sign here to insinuate 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. Okay. All right, so let me just back up and kind of go over what I just did. So I started by looking at as x approaches 6 of the function. Okay, and I see that I got 2, and that plus sign is coming because those guys are higher than 2. Now, this f of x is this f now. okay, because we already did this part. So I'm just looking at that part now. Okay, so now once we do that, we are going to go back and look at this picture and look at what happens as x approaches 2 from the positive direction. Well, here's x equals 2, but from the positive direction, let me put this in another color. From the positive direction means this piece of the graph, okay? And then if you look at that, what y value is that going toward? And you should see that it's going toward a y value of 5. I think that looked like a 5. Okay, there's your answer. All right, so if we look at C, you should see that you've got this graph here, right? Isn't that gorgeous? Anyway, I'm going to be honest with you. I would ask him on this question. I'm not 100% sure. Okay, and so I want to go according to this method that I was using here, and that you can use for the rest of these. But this one, please just do me a favor, double check and ask him. And then come to me and you can tell me what he said. All right, so I'm going to go down to 2 here. All right, this is 1, 2, 3, 4. All right, so I'm going to go down to 2. So this is as x approaches 2. Notice that there's no positive or negative, which like this one, then we need to come from the left and we need to come from the right. So I don't messy up my picture. Here we go. So here's x equals 2. Coming from the left and coming from the right, do you see him approaching a y value of 1? Okay, so then over here, I'm going to write this as the limit of k of x as x approaches 1. Now, let's just hold that thought for a second. So I'm getting this 1 by taking the limit as x approaches 2 of this k of x. So once I do that, that disappears. So this k here is that one right here. Okay. Now let's go back to what I was talking about here. So the limit as x approaches 2. So here we go. X approaches 2. X approaches 2. I don't want to dot on this picture because I still have to do these and I don't want to get it all yicky. So pretend like I'm dotting, dotting, dotting. Do you see all of these y values are higher than that one? And all of these y values are higher than that one. So these are bigger than that y value. So in that case, like this one, I'm going to be putting a plus sign. Okay, so I'm going to put a little plus there. All right, then the last part is we're going to look at k of x again and find out what the limit is as x approaches 1 from the positive direction. So here's 1. From the positive direction would be this piece right here. And if you look, if I go 1 from the positive direction, I'm going to a y value of 2. So the final answer to that question should be 2. You can double check with him. I'm pretty sure I'm right. I Googled it, but anyway, you never know. All right, so let's look at Roman numeral 3. So we're going to do the same thing again. So let me just set, oops, put my pen on there. We're going to do the limit k of x as x approaches. All right, so here we go. So we're doing this one right here. As x approaches -1 from the negative direction. So I'm going up here. Here's -1. From the negative direction, that's this piece right here, because that's to the left. And now watch what I'm doing. Do you see I'm approaching a y value of 0? Okay, so I'm going to put a 0 here. Now, let's go back to that graph again. Look at what's happening. Are these y values higher than 0 or lower than 0? Hopefully you're saying higher, in which case I put a plus sign there. All right, then the last part is just to go back to the original picture and approach 0 from the positive direction. So here's 0. From the positive direction is this graph right here. From the positive direction, look, what's that y value? That y value is equal to 1. Okay? Alrighty, so part 4. we're going to do this exactly like we did part 2 and part 3. So remember how I found the limit of this k of x first. So I'm going to find the limit of this cosine x first. So what I'm really doing is I want to know what's the limit as x approaches 0 of cosine x. Okay, so I drew the picture over here just so that you could see it, similar to the sine x. All right, so oopsie, I forgot to write 0. There we go. All right, so we're looking at the cosine of x, and as it approaches 0, now there's no little plus or minus, so that means we have to come from both directions. So if I come from the right toward an x value of 0, I approach a y value of 1. And if I come from the left of 0, as I get closer to it, I also approach a y value of 1. So hopefully you see then that this would be 1. Okay? But then the last thing that we have to, so we know that it's going to approach 1, right? Approaches 1. Now look at all of the y values here and here. Are they bigger than this 1 or less than this 1? And notice that they're all less, they're lower. So what that means is when we're doing this last limit, we want to have a negative there. Okay, so now what we're going to do is we're going to take the limit of k of x as x approaches 1 from the negative direction. Here's our k of x. X approaches 1 from the negative direction would be this piece right here. And as we're getting closer to x equals 1, look at what that y value is. Okay, and that y value is going to be a positive 1. All right, so now somewhere in your packet, you're going to see these two. Okay, so find them. Pause me, find them. Okay, what I want you to try is try doing both of these. So I want you to pause me and see if you can come up with an answer. Okay, and then once you get them done, unpause and see if you're right. Okay, so since it's 0 and there's no positive or negative, we need to come from both sides. So I see that I'm approaching a y value of 2. Oops. So let me put a 2 right here. Okay, you can write it next to here like I had been doing. I just didn't have enough room. So, normally I'd write it here, but I'm putting it under here. Okay, so 2. Now notice this y value, or these y values, and these y values are lower than 2. So lower than 2 means from the negative direction. All right, so now what we're going to do is we are just going to look at the picture again and approach 2 from the negative direction. So here's 2 from the negative direction, and that goes to 0. Okay, 3B, I'm just not going to even attempt this one. This is like the other one that I said to ask him. I'll explain why I'm saying that. All right, so look, as x approaches 0, right? So if let me just get my color pen here. As x approaches 0, it doesn't say from what direction. So I'm going to come from the left and I have to come from the right. So then my thought process was that, let me just get my black pen back on. This then would be a 2, right? But here's the problem that I'm not 100% sure of. So I don't want to tell you the wrong thing. Here, the numbers are less than that y value of 2. And here, the numbers are greater than that y value of 2. So like, I'm not sure if you're supposed to put a plus here or minus here. So that's where I'm a little confused, because online it said that then from here we just take the limit of the function as x approaches 2, and as x approaches 2 we're going to 2 different y values. So they're saying this answer is D and E. That may be right, but that may be wrong. So I want you to double check with him if you don't mind on that one. Okay, and then get back to me. All right, look, I figured out how to take a picture so you didn't have to see my cruddy pictures that I was drawing. All right, so you should find this somewhere in your packet. This one was number 10 and this one was number 11. All right, so probably for number 10, I'd like you to pause me and try this because it's very similar to the ones that we were just doing. And then you can check with me for the answer. All right, so I got C as the answer choice. So I started by looking at it as x approaches -1. So that would be going this way. Ooh, I picked a bad color. Let me see if the blue will be better. So I'd be going like this, do 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 do. Oh, that stands out nicely, right? And then this way. And do you see that both of those arrows are pointing toward a y value of 3? So then I'm like, all right, well, then that means the limit of f of x as x approaches 3. But now, if you look, all these numbers here and here, all their y values are lower. So I would be doing a negative there. Okay, so then from there, I just pop over to 3 from the negative direction. So here's 3 from the negative direction is this piece, and that's going toward a y value of -1. And there would be your answer. Okay? All right. 11. I Googled, I chat GBT'd, I photo mathed, and nobody ever had the same answer for number 11. So this, again, may be one that you may want to ask him. I have DNE, and that's what I tend to stick with, but I might be wrong. So it, in my mind, the answer is D. So when you see something like this is different than what we had. This is a composition. This is f of x. This is not of anything. This is f of x times g of x. So technically, when you have that, that's really equivalent to the limit. This I know for a fact, so I know I'm right here, of f of x as x approaches 0 times the limit of g of x as x approaches 0. And what you're supposed to do is just get those two answers and then multiply them together, boom, done. All right, so this is the part that I think is, I'm a little, I'm going to talk about this part first. So if I go over to x as x approaches 0, there's no little plus or minus here, so I have to come from the left and the right. And do you see it goes to a y value of 0, right? Okay, so I know I'm right on that. Boom. Here's the part that I'm like, hey, what? As x approaches 0, here I'm going to a y value of 0. But as x approaches 0 from the right-hand side, I'm going to a y value of, hold on, 1, 2, 3, 4, 5. Okay? So this and this, that limit doesn't exist then in my mind, because the limit from the left doesn't equal the limit from the right. And in order for a limit to exist, this left-hand limit and the right-hand limit have to be the same, and they are not. So then in my mind, that would be a DNE. And a DNE times 0. So anything times 0 is supposed to be 0. So I guess it's possible that it's this, but I don't know why I'm leaning toward the DNE kind of ruling the roost here. I could be wrong. All right. I really hope that was helpful. I didn't bore you to death. Okay, bye.